Hello, welcome back. This video covers section 10.4, slope-intercept form of a linear equation. Slope-intercept form of a line, we have two different ones we're going to talk about. The standard form of a line, the equation of a line written in the form ax plus by equals c, where a and b are both not zero. And then we have slope-intercept form of a line. That's the equation of a line written in the form y equals mx plus b, where m is the slope, and the point 0, b is the y-intercept. And so I just want to point out that if I had y equals 2x plus 5, that my slope would be 2, and my y-intercept would be 0, 5. So this is the m, and the plus 5 is the b. All right? Okay, so for number 1. It says, identify the slope and y-intercept if they exist. Y equals x minus 4. So we can directly use y equals mx plus b. And the number in front of x is a 1 because there's nothing there. So my slope is positive 1. And then my y-intercept is this part of the equation, which is negative 4. And so b is negative 4. But the y-intercept, a lot of times we write as an ordered pair. So 0, negative 4 for that one. All right, so for number 2, we have 3x plus 2y is equal to 9. And you'll notice it's not in slope-intercept form. So there's this really neat formula that says when you have ax plus by equals c, the slope is equal to negative a over b. All right, so you can actually take the coefficients that are in front of a and b and just put a negative in front of that. Okay, so for example, I have 3 and 2 are a and b, and the slope is equal to negative a over b. So a is 3, but there's a negative there, and b is 2. So my slope is negative 3 over 2. Now, to find the y-intercept, we can actually plug 0 in for x. So if you imagine, if I plug 0 in for x right here, I'm just going to have 2y equals 9, and then I can divide both sides by 2. And so my y-intercept is 9/2, which I could also write as 0, 9/2. All right. Now, number 3, they're a little bit trying to trick us here because you'll notice there is no y. So I'm going to get x by itself, and I'm going to end up with x equals 6. And I hope you remember that this is special. This is a vertical line. And so if you remember, vertical lines look like this, and that slope is actually undefined. And since this is a vertical line at x equals 6, there is no y-intercept. And so you're kind of using our past knowledge to understand that there is no y-intercept for that one. All right, so let's graph a line from its slope and y-intercept. To graph a line using slope and y-intercept, you first plot the y-intercept 0, b. Then you can use the slope to find a second point on the line. For example, on 4 and 5, we're going to graph the line through the point 0, negative 4, having a slope of 3. So you can see that they've placed at negative 4, that is the y-intercept, and then they counted the slope. Since the slope is 3, you can actually think of it as rise over run, and the denominator on the 3 is a 1, because there is no denominator. So that would mean up 3 to the right 1. So they went up 3 to the right 1, and they plotted a new point. And then this would continue. Up 3, 1, 2, 3 to the right 1 would be another point. And then up 3, 1, 2, 3 to the right 1 would be the last point. Okay, so that's how we can plot the graph. So on number 5, they did a similar thing. The ordered pair 0, 2 is our y-intercept, which is right here. But this time the slope was negative 2 over 3. So that would mean down, because it's a negative, so down 2 and then to the right 3. So you can see they went down 2 to the right 1, 2, 3 and have a new ordered pair, and this would continue on in both directions. Okay. So for exercises 6 through 8, we're going to match the equation with the graph by identifying if the slope is positive or negative and the y-intercept is positive, negative, or 0. So we're just matching the graphs. All right, so for number 6, we have a positive slope. So remember, if the slope is positive, it's going to look like this. If the slope is negative, it's going to look like that. So we have a positive slope here. So our slope is 3, and our y-intercept is negative 2. So I'm looking for a y-intercept of negative 2, which kind of narrows it down. This is about at negative 2, and you can see the other two graphs don't even have that. And then it is a positive slope. So 6 is B, so this would be number 6. And then for number 7, our slope is positive 1, and our y-intercept is at 0, 3. And that could be really either one of these, but this has a positive slope. And so for number 7, that is at A. And then by default, 8 would have to be C. However, we have a negative slope, which this is showing here, right? So negative slope. And so you can see that it's going down. It would be like if you were here and you were going to run on this slope, you'd be running downhill, right? So that's a negative slope. And then the y-intercept is positive 1, which is in the correct spot as well. All right, so for exercise 9 through 11, we're going to write each equation in slope-intercept form if possible, and we're going to graph the line. All right, so for number 9, I'm probably going to use my little handy m equals negative a over b to get the slope. So a is negative 3 and b is positive 1. And so I'm going to have negative a over b, which is negative 3 over 1, which becomes a positive 3. So my slope is positive 3. And then to find my y-intercept, I'm just going to replace x with 0. And I can do this pretty quickly, actually. So if I put a 0 here, then y is equal to negative 4. So my y-intercept is 0, negative 4. So my slope-intercept form would be y equals m, which is 3, x, and then plus b, except for, of course, b is negative 4. So y equals 3x minus 4. All right, so at 0, negative 4, I'm going to place my ordered pair. That's my y-intercept. My slope is positive 3, so that would be 3 over 1. So I'm going to go up 3 to the right 1. So up 1, 2, 3 to the right 1 would be right here. Up 3 to the right 1, up 3 to the right 1. And then I can connect my ordered pairs from that. All right, number 10. Now, number 10 is not really in any kind of form, but I want it to be in slope-intercept form, which remember is y equals mx plus b. So on number 10, I'm going to divide both sides by 3. Then I have y equals negative 2/3 x. But if you think about it, I can see that my slope is negative 2/3, but there's like an invisible plus 0 here, right? This is invisible. So that means that my slope is negative 2/3, and my y-intercept is actually at 0, 0. So I'm going to have a 0, 0, and then I'm going to go, since it's a negative 2, I'm going to go down 2 to the right 3. So down 2 to the right 3, and down 2 to the right 3, or, whoops, sorry about right there. I could also go up and to the left to get another ordered pair on my graph. So what's cool about it is you can either go down and to the right, or you can go up and to the left, and you'll see that it falls on the same line. All right, number 11. I need to get y by itself to get it into the slope-intercept form if possible. So I'm going to go ahead and subtract 10 from both sides. And so I get 2y equals negative 10. And then I'm going to divide both sides by 2. And I get y equals negative 5. So I have no x, all right? So if you remember from our past section, this is a horizontal line. So let me draw this for you. So here's my horizontal line at y equals -5. The slope is 0 for horizontal lines, and then my y-intercept is 0, -5. All right, let's try some more. Okay, so on 15 through 17, we're going to write an equation of the line in slope-intercept form given the following information. Okay, so for number 15, we have that the slope is 2/5 and the y-intercept is 0, 4. And our goal is to write it as y equals mx plus b. So given that our slope is 2/5, that number goes in front of x. And then our y-intercept is 4, so it will just be plus 4. So remember, this is our b value right there. All right, let's try number 16. Okay, so our slope this time is -4, and our y-intercept is -2. So that would be y equals -4x. And this time, since b is -2, we just put a -2 to show that. Okay? And then number 17, the slope is 0, and the y-intercept is 0, -3. So if the slope is 0, you could think of it as a 0x minus 3, because that's our y-intercept. But since it is a 0, this part goes away, and we're just left with y equals -3. So remember, if the slope is 0, that does become a horizontal line. All right, and then we've got this word problem. It says a taxi cab company in San Francisco charges an initial charge of $3.50 plus $2.75 per mile. The equation C equals 2.75x plus 3.5 represents the total cost of the taxi ride C for x miles. So first, it says to identify the slope, interpret the meaning of the slope in the context of the problem. All right, so the slope would be this part, right, because it's mx plus b. So the slope is $2.75, which if I'm going to interpret that, then I would say that that's the cost per mile. And I shouldn't even use the word increase. So maybe the cost increase per mile. All right. Identify the c-intercept, which I think they mean b-intercept. I don't know. Interpret the meaning of the c-intercept in the context of this problem. All right. So the c-intercept would be the 350 part. I think they mean y-intercept, but that's okay. So the y-intercept is $3.50, and I could write that as 0, 3.5. That is the base fee for the taxi ride. So you pay $3.50 even if you just sit in the taxi and don't go anywhere. And then determine the total cost of the taxi ride if it's 12 miles long. So if x is equal to 12, then I can just plug 12 in to determine the cost. So it would look like this. And I would use a calculator, and I end up with $36.50 for the total cost. All right, I hope this video helped you, and I hope you have a great day. Bye.